Adding and subtracting radicals. So to add or subtract a radical, a few things have to happen. The index needs to be the same, the radicand needs to be the same, and you can only add and subtract the coefficient, so not the radicand. So as an example, it says simplify. You can once again have to have the same index and the same radicand. So in this case, we have a square root of 3 and a square root of 3. Therefore, I can add the two coefficients together to get 8 square root of 3. I have a square root of 5 here that's not the same as the square root of 3, so they cannot be added together because they are not like terms. And so this is as good as it gets. That's adding two radicals together. As another example, we have the cube root of 2 and a cube root of 2. These are like terms, therefore I can add or subtract them. In this case, it's 2 minus 5. So I'm going to go ahead and do that, getting a negative 3 cube root of 2. And then since here I have 3 square root of 7, these can't be combined for two reasons. One, the radicand is different. One's a 2, one's a 7. And also the indexes are different. The index here is a 3, the index over here is a 2. Therefore this is as good as it gets, and that is adding two radicals. Here we have another situation where you will notice right off the bat that we have a square root of 75 and a square root of 27. They are not the same, but they're pretty decent sized numbers, which means I can probably simplify them and then they might be able to add together then. So here, two numbers that multiply to be 75 would be 25 times 3, and 25 is 5 times 5. So therefore I have a pair of 5s that I can circle, and so I will have a 2 outside the radical, and I'll also have a 5 to represent that one circle. I have a 3 that couldn't be circled because it had nothing to pair up with, so it'll stay inside the radical. I'll do the same thing over here. I have 3 times 9, which is 27, and then 9 is 3 times 3. Here I have a pair of 3s. Therefore, I can take a 3 outside of the radical. So I will bring down my minus 5, and I'll now put a times 3 out there. There was a 3 that couldn't be circled, so it will stay inside. Now I'll clean up the problem a little bit. 2 times 5 here is 10 square root 3. And then I have negative 5 times 3, so that's negative 15 square root 3. Now I have like terms. They have the same index, and they have the same radicand. So now I can go ahead and subtract them. 10 take away 15 is negative 5 square root 3. Over here, I have an index of 6 for both of these, but they are different radicands. But 320 seems like a big number, so I can probably make it smaller by simplifying it. So I could do 10 times 32. 10 is 5 times 2. 32 is 4 times 8. And 4 is 2 times 2. 8 is 2 times 4. And 4 is 2 times 2. This time, once again, the index is a 6, so I'm looking for 6 of the same number, which I have right here. I have 6 2's. So I will bring a 2 outside the radical. So I have negative 2 times a 2, representing the one that I circled, with an index of 6. And then I have a 5 that didn't get circled that will stay inside the radicand, inside the radical. I bring the other one down, and I just clean it up a little bit. I have my 2 6 root of 5 minus 2 times 2 is 4. 6 root of 5. They have like terms. They are both indexes of 6 and a radicand of 5. So I can go ahead and combine these. So 2 take away 4 is negative 2. Radicals, index of 6, 5.